So I request Harun Shia to present his work. He's from Textile, right? Yeah, he has a BSc in textile and languages. So I request him to present his talk now.
Assalamu alaikum. Myself, Mohammad Harun Rashid Riyad. I'm from Bangladesh University of Textiles. And today I'm going to talk about our research work on devising a vibration-based fault detection system for textile machinery. Let's look at what we're going to discuss today. Firstly, we're going to talk about the motivation behind our research. Then with some studies that similar works but solve the problem. Try to solve. And after that, we're going to see an illustration of our methodology, how we try to solve the problem. And finally, we have also applied our system in real industrial scenario. We're going to look at that. And finally, we're going to see the findings that we found from it. So there are different types of machineries in textile industry, like weaving machinery, dyeing machineries. All these machineries are consist of 4 mechanical components which are directly responsible for the fabric. Now, whenever there is a fault in any of these components, it results in the production of faulty fabric output. And faulty fabric output means stop of production. Stop of production means loss of profit for the business. So it's really important for us to detect the machine fault before any faulty fabric output is produced. If a faulty fabric is produced due to the fault machine. Now, in our research, what we try to do, we follow the core concept to detect the machine fault by vibration. Now, what you see that there is a standard amount of vibration for every machine. And this standard amount of vibration depends on the structural dynamics of the machine. So whenever there is a fault in any component of the machine, the structural dynamics of the machine changes. So as a result, whenever there is a fault, the vibration of the machine should change. And we try to find out that if the vibration does really change. So similar works have been done before. We can talk about the vibration-based fault detection system. But the problem of existing vibration-based fault detection systems are that they're mainly based on industrial data. So they don't really work really well in real industrial scenario. Plus, they don't really detect the type of fault that is occurring. So it's really difficult to identify which part we remedy the machine. There have been approaches of photoelectric-based fault detections, but these approaches are quite complex to implement in real industrial machine and they're quite expensive. So in Bangladesh scenario, it's really more complicated. And finally, there is a different approach of detecting machine fault, which is fabric defect-based fault detection system. What is done here is that firstly, we detect the faulty fabric on the machine, and from that, we can determine that the machine is faulty. But the problem of these approaches are that the fabric already becomes faulty before machine fault. So it results in the loss of production anyway. So what we try to do that we created 6 real faults in the machine, and we measured the vibration during those fault conditions. And after that, we did fast Fourier analysis. From that, we found out the machine frequency during those fault conditions. We also did statistical analysis to extract the statistical features. From these 2 analyses, we found out if the machine vibration changes due to different faults in the machine. And after that, we applied our data set into 8 different machine learning algorithms so that the machine learning algorithms can detect the machine fault. Now, here's an illustration of our methodology. You can see that we have installed our vibration sensor accelerometer in single disk accelerometer machine, and we use Arduino R3 as our control module. And after that, we created the 6 real faults in the machine, and we measured the vibration during that time. And we stored the data in our computer. And after that, as I talked about, we use fast Fourier analysis and statistical analysis. Fast Fourier analysis tells us about the machine frequency during different faults. And statistical analysis also gives us about the different statistical features during different faults. And then we applied our data set into machine learning algorithms. We trained it. And finally, we evaluated our machine learning algorithms by 10-fold cross-validation, calculate the accuracy, precision, and recall. These are the 6 faults that we created in our machine. Now, the main components of a knitting machine are needles, sinkers, and cam. The main frequent faults really occur on the needles and sinker of the machine. So we actually created the most frequent faults that occur in the industry every day. We pulled out a completely fine needle from the machine, then measured the vibration. We used a hook broken needle, a latch broken needle on the machine. In sinkers, we used a faulty sinker on the machine and the butt broken sinker on the machine. And due to all these faults, during all these faults, we measured the vibration of the machine and created a data set. And here you can see that we are computing data in real industrial scenario, and we went to sadly situated in Gazipur. Now let's talk about the fast food analysis. Now what fast food analysis does is that it divides the vibration signal into its own individual frequency components. And from that, you can actually find out the vibration frequency on the machine during the faults. And as you can see in this graph, that the vibration actually varies during the can see from this graph, and it will be more clear in this graph. You can see that the vibration changes in both vibration amplitude, vibration frequency during different faulty conditions. And in terms of sinker fault, it's the same. You can see that the vibration amplitude and frequency changes during different faults. Now, as we did that fast food analysis, we kind of became sure that the vibration changes during different faults, but we had to be more sure about it. So we did statistical analysis after that. On statistical analysis, we extracted these features, and you can see that in these features also the vibration varies during the context. You can see that in the mean acceleration, the mode acceleration, and all the produces units, and also the standard deviation. Now, after that, we have actually established from these two analyses that the vibration varies due to the fault. So we applied our data set for training 8 different machine learning algorithms. And after training that, we needed to find out if our algorithms work really well. For that, we evaluated our algorithms using 10-fold cross validation. And you can see the decision tree classifier algorithm performs excellently well in terms of detecting the fault, and it has a really high decision recall and F1 score. And the gradient boosting algorithms also perform really decent. So as a conclusion, actually, we can say that our system is much more better than the existing system because it instantly detects the machine fault just by using the vibration. And it also can detect the machine fault before any fault traffic output is produced. Also, in the future, we are actually hoping to develop a more advanced fault data set by varying the machine RPM while creating the different faults so that our system becomes much more accurate and much more effective detecting the machine fault. So this will be our presentation. Thank you, everyone.